Evening friends, welcome to 360DigiTMG. Today we are going to understand about the optimizing large language models using, and we are understand about the how to do a parameter tuning. Okay, what are the different ways for tuning our parameters within our LLM large language models? So this is our agenda. So firstly, we'll introduce what is LLM first. What is the large language models? So large language models are the advanced artificial intelligence systems that are categorized by an extensive numbers of parameters that has been trained on extensive or more numbers of parameters. These models will undergo training on extensive data sets. It can be textual data set. Okay. It can be a data set coming from different domains, which will enable them to understand and can generate, or we can say, or can manipulate a human-like text with a high degree of complexity. Okay. So these are some of the significance of the LLM models. Okay. So we have revolutionizing NLP, natural language processing, which will transform how our machine understands and generates human-like language. It will enable a sophisticated and conceptually aware interactions between users, as well as even if you are preparing any chatbot or other things. So we can have a sophisticated understanding between the user, what is user saying while using an LLM model. Then efficient content generation. So when we are putting our model and when we are making like whatever the thing from the user's input, user will input or prompt something. So from that prompt, we can generate certain contents. That content can be relevant to text creation. We can form and impacting in marketing, journalism, creative writing. Likewise, we can use it in various domains. Then we can even use this large language models for language translations. Like if you want to use it for from one language to the other language, from Korean to English or from Spanish to English, likewise, we can do with respect to our LLM models. So see, we are going to search what will be the user will ask some input. We will classify it. We have some predictive models as well as generative models. Okay, we will collect our database. Okay, this will be data sources from various other different sources will be there, like Wikipedia. We can have a multiple papers from there. We can fetch our data set, and we can use it for predictive analysis, and we can use it for generative or for generations, Gen AI, for generative analysis. Okay, generative analysis will generate contents, like it can summarize our text, it can rewrite, it can extract some contents from here, it can form a cluster, it can be useful for question answering, and so on and so forth. Practical applications of large language models. So first is our chatbots for customer support. We can prepare a chatbot by using our LLM model, okay, which can use and supports our e-commerce sector. Okay, then we have already for Amazon, for different platforms, we have that. Even in our website also, we have an AI tutor, okay, which is one of the chatbots only. So how this chatbot will work? The LLM will enable the chatbot to understand and respond to customer queries in a natural language format, whatever will be the language of the customer. It will raise some query in a form of natural language, which will provide then the context to the databases or to the LLM model. After that, it will fetch some semantic search and it will provide some uh, information regarding the context. Okay, and when we are using this, it can provide us accurate as well as conceptually relevant information. These chatbots and other things can be useful for repetitive tasks. Okay, repetitive question answering task. For that purpose also, we can use this. Then we have automated content creations for marketing. So we can see the applications of this It can utilize our LLM to automate the creations of marketing content. Okay, like the model can generate an engaging and conceptually relevant marketing copy, social media post, or product descriptions. This not only saves time but also ensures consistency in the brand messaging, which will contribute to effective marketing campaigns. Okay, then we have our language translation services. As I said, we can use it for like the data set here will be a multilingual data set, which can be from different domains, which will allow it to accurately translate text from one language to the another language. And this application is particularly beneficial for breaking down the language barrier between international domains. Okay, like if we are traveling, if we are using our online content or anything, there should be not language barriers between the two persons. So for that, we can use this LLM models so that both can interchange their languages and understand what they are saying. These practical applications will demonstrate the real-world utilities of LLMs across various domains. How do LLM parameters work? Now, how this LLM parameters work? So LLM parameters refers to the internal variable that is there inside the large language model. It used to learn and understand the language pattern. What is the language pattern? Okay, likewise. Then LLM will possess an extensive neural network with millions and even billions of parameters it has been trained on. These much parameters our model has been trained. Okay, so representing the model's capability or model's capacity to grasp and integrate the language structures. Okay, so as the model has been trained on more parameter, it can give you a good result. Okay, so during training, the parameters are adjusted during the process called as backpropagation. As we know what is backpropagation, how we'll do, why we do the backpropagation is we want to minimize the losses between the what has been predicted to that of what is the actual outcome. So we want the difference of these two should be lesser. For that, we will do a backpropagation every now and then so that our predictions as well as outcome both should be equal to each other so that our losses will be lesser. Parameters encode linguistic knowledge, capturing syntax. It can use semantic search. It can have a conceptual relationship, which allows the LLM to generate coherent and conceptually relevant information or conceptually relevant text, whatever the user is asking for to generate. Likewise, LLMs excel in conceptual understanding due to vast numbers of parameters. It enables them to understand broader context and dependencies within the sentences. Yes, we can fine-tune. Fine-tuning we can do to these models. So fine-tuning will involve adjusting the parameters. Now we will understand from now onwards, we will understand how we are going to adjust the parameters and what are the different parameters within our LLM models so that we can fine-tune our model. Okay, which will allow what it will do, adjusting the parameters to a specific task will allow LLMs to specialize in various language related applications, like for example, translation, summarization, question answering, likewise, and so on and so forth. If you want to if you want some image to be generated, likewise. So there are multiple applications of this. Then LLM parameters are often pre-trained on large text corpora. Okay, it has been text on large data set, large data text corpora. Like we have a huge numbers of data set. We can take it from everywhere. Okay, so instead of like training, directly starting and scratching training, what we can do to this big model, we can use our transfer learning and we can apply our acquired knowledge to a specific, like what is our business problem. According to that business problem, we can leverage our transfer learning. Okay. So these are the LLM parameters, large language model parameters. Okay, model size, numbers of tokens, context windows, frequency and presence penalties, stop sequences, top K and top P, and temperature. We'll understand one by one. First is our model size. So as we have understood that the model size which the model has been trained on, okay, so the model size of LLM will refers to total number of parameter it possesses. Okay, the parameters are variable which learned by LLM during training itself. Okay, it has different numbers of parameters. As we say, ChatGPT has this many numbers of parameters. Likewise, it will influence. So more the parameters, more will be our model, more good our model. So it is a fundamental characteristics of an LLM. Okay, so now how we are going to measure this model size? So model size is commonly measured in billions or trillions of parameters. A larger model typically indicates that better performance, but it demands more substantial computing resources for training as well as execution. Like if we are using a larger models, we can't use directly in our local system. Okay, we have to use a GPU instance or a TPU instance. Okay, so that is one of the things. Then the significance. The model size plays a crucial role in LLM's ability to understand and generate the human-like text. It directly impacts the complexity and nuances of the language expressions that the model can handle. Then we have a task suitability. Different LLMs have varying sizes, making them suitable for specific tasks. Like, for example, we have GPT-3, and it has been trained on 175 billion parameters. Likewise, different models will have different parameters wherein they have trained on. Okay. So what is performance versus resources? Okay. So while we have a large model, generally will enhance our performance. Larger the model, more the performance. It comes with a trade-off of increased computational requirement for both training as well as inferences. Okay. Yes, as we have told that if the model is larger, we have to use GPU or a TPU instance. It cannot run on a local machine. So the choice of the model size will depends upon the specific applications and what are the available resources we have. Okay, so if you want to choose the model with less parameters, so that depends upon what applications you are running, what is your business problem, how much accuracy you want, likewise. Then the second term is temperature. Temperature parameters that influences the randomness of the output. Okay, what is the randomness in the output which has been generated by the large language models? So there are certain ranges. Like if we have a higher temperature, what it will do? It will have a more creativity within a whatever will be the generated text or whatever will be generated output. It will have more creativity, but it will have more randomness also. Okay. And if we are using a lower temperature, it reduces the randomness. So it will be more focused and deterministic text will. Whatever will be the generated text, it will be more focused and deterministic text will be formed, which will emphasize the accuracy as well as adherence to the factual information. Then use cases of the higher temperature. As we can use this higher temperature is useful for, like we can use it for creative writing. If you want to use it for like creative writing, we want some like things which are not usual. Okay. So for that purpose, we can use it for brainstorming. We can use it for generating the diverse idea. Likewise, we can use it. Okay. And the lower temperatures, which is suitable for factual accuracy. If we want accurate text, accurate summarization, if we are more focused towards the accuracy side, we have to take the lower temperature. Now, choosing the right temperature depends on the nature of the task and desired output characteristics. Then the iterative experimentations has been needed for what has been generated to find the optimal temperature settings for the particular use cases. Like what we have to choose for the particular use cases, that depends upon our business problem. Okay, and we can play with this. Like this is like a one of the hyperparameters. Okay, so we can adjust this and check whether what it is giving, what it is generating likewise. Now we have top K and top P. Okay, so top K will do what? Top K will select the most likely tokens from the LLM's predicted distributions. Okay, now what is the purpose of this top K? It will ensure the high quality and relevant output. Okay, suppose we have some non-sensible items there, okay, which is not required. We will avoid that tokens there and then. Okay, it is ideal for precision focused scenarios. Then we have top P, which is a nucleus sampling, which retains the tokens with total probability above a threshold point. Okay, we will give one threshold value. Okay, within this threshold value, if the value is, we will take it, otherwise we will skip that value. Okay, like what is the purpose of this then? It will promote the diversity in the generated text. It will explore the varied responses, useful for tasks requiring a large range of potential outputs. Okay, then we have a balancing strategies wherein users can dynamically combine both the things together. Like we can use K as well as P, top K and top P as well. Okay, so top K will remove the non-sensible, or it will avoid the things which are like, which is not, which is like harmful, or which cannot be shared by the LLM model. Like if there is gun or some illegal languages are there, we will skip that thing. Okay, and second, top P will do what? Top P will take, if the if certain objects are there which is not that relevant, which is not occurring in the text more times, we will skip that item also. Okay, then we have number of tokens. Tokens are linguistic units which will include words, punctuations, and numbers, which will constituting the vocabulary on which large language model is trained. This serves as a fundamental building blocks for the model's comprehension and generations of the text. Okay, so how we'll take the number of tokens? So we have vocabulary size variations. Okay, so if the number of token in an LLM's vocabulary can vary widely, or ranging from few thousands to several million tokens, likewise. So a larger vocabulary will imply more extensive repository of linguistic elements about the model, available to the model. Okay, then we have impact on text generations. Okay, what impact will grow to our text generations? The larger tokens, if we have a larger numbers of token counts, it enables the LLM to generate more creative and accurate text. Okay, more token, more accurate. Less token, less accurate. More parameter, more accurate. Less parameter, less accuracy. Likewise. Okay, so computational resource requirement. The size of the token vocabulary directly influences the computational resources which needs for training as well as execution. Now, if we have a larger vocabulary, demands for substantial computational capabilities as well. Okay, so our computational capability should be that much high. Okay, so if we are taking large vocabulary, it will lead to more computational capabilities like GPU or TPU, like I have said. Okay, then language understandings and GPU example. Okay, the number of tokens in an LLM vocabulary significantly impacts in its language understanding. Okay, if the model is trained on 1.5 billion token vocabularies, for example, it will give you, it will implies you how a larger vocabulary broadens the model's comprehensions. It will enable it to grab like wide spectrums of words, phrases, likewise. Okay, more like it has been trained on more numbers of token vocabulary, it is more beneficial for us. to generate our output in a realistic way. Then context window. Context window. Now, context window refers to the number of words considered by the LLM during the text generation. What is the number of text, or what is the number of words that we have considered within our LLM model to generate the text? That is also very important. Okay, so it will impact the text generation. If we'll have the larger window, it will give you a more conceptually relevant text. If we'll have the less context, for example, if we'll have the less context, it will not generate, or it will give you output, only half output it will be generating. Okay, not the entire output will be generated. Likewise. Okay, then context window in a conversation. Larger or longer context window enhances the coherence in the conversational context. And it will particularly valuable for chatbots, which maintains the conceptual understanding within each other. Okay. So context window is a critical parameter which will influence the relevance as well as coherence of the LLM's generated text. Okay. Then we have a frequency and presence penalties. Okay, so here in the frequency penalty, we have two penalties. Here we have a frequency penalty and we have a presence penalty. So in a frequency penalty, here the objective of this frequency penalty is the LLM will use this penalty for generating frequently used words. What are the frequently used words? Okay, and the purpose of this is it will prevent the generation of the repetitive or overused text. So that what will occur? It will encourage the less frequent tokens. Okay, which the tokens which are having less frequently asked tokens. So it will generate only tokens which are unique. Okay, it will not use the tokens which are very repetitive or overused. So that is how we can reduce our computational resources which we have, which is demanding. Okay, in our LLM model. This is how we can reduce that. Then we have a presence penalty. In a presence penalty, we have a penalties for LLMs for generating words which are not used recently. Means the words which are outdated or which are irrelevant. Okay. So in language translation, a frequency penalty ensures the utilizations of rare words. Okay, rare words, or what we can say are unique words only, which will enhance the translation accuracy and variety of the words. Okay. These penalties play a crucial role in shaping the relevance and diversity of the LLM generated text, which will offer control over the token selections, which tokens we are taking. Okay, based on the frequency as well as recently considerations. What are the recent considerations according to that? Then we have a stop sequences. Stop sequences. So stop sequence is one of the parameter or hyperparameter, what we can say. So here stop sequences are predefined parameters or sequences that LLMs are programmed to avoid during generation or generating. Okay, like we can say how we have a stop words likewise. Okay, these sequences often include sensitive as well as undesirable content as well. Okay, such as profanity, offensive language, or any information that should be restricted. So that information should be restricted. That information we will not take. So we will stop that sequence info. We will use a stop sequence parameter so that this offensive language will be gone. Okay. So implementation, how we're going to implement this? In applications like content moderation systems, stop sequences acts as a preventive measures. Then programmers specify sequences that, if generated, would result in harmful or inappropriate content. LLMs are trained to recognize and abstain from producing text containing these stop sequences. Like we can't use the language which is like, we can't use bias also. Okay, bias thing is also avoided here. Okay, like we can't use the offensive language. Like if someone is giving a prompt like I want to create an item bomb. Okay, so what are the steps? Please tell me. So our model, our LLM model will never going to give us the output. So it will stop the sequence there and then. Okay. So what are the use cases? The profanity filtering, like profanity filtering, what it does, it will stop our sequences that can be designed to block the generations of profane language. It is essential for maintaining a respectful and safe environment in online platform. So that is why we use this. Then sensitive information. Certain sequences might represent sensitive information like personal detail, financial data. So this should also be, we will stop this information. Like sensitive information also will be, we'll use the stop sequences and we'll stop this. Okay. Stop sequences helps in preventing the accidental disclosure of such information. Okay. This should be avoided. Okay. Now, there are some challenges as well. Like overly restrictive, if we are overly restricting our model or overly restricting our stop sequences, suppose if we have false positive also. So what we are doing may lead to false positive. If if that information is not that harmful, still we are filtering out that content. So that is one of the challenge. Okay. That is one of the challenge that should be taken care of. So this is it, guys, for today. Thank you for joining. We'll see you in next lecture with new topic.